When we talk about email, we're really talking about a very old but very successful application layer system for moving messages over IP networks. It's not magic, it's just a carefully choreographed relay race. Conceptually, the flow looks like this: sender, mail server, internet, recipient's email, server, recipient. You write a message in your mail client. Your machine hands it to a server, and then a series of servers negotiate how to get the message to the destination domain. It's what we call a store and forward model. Each server along the way stores the message temporarily, then forwards it closer to the destination, a bit like how cargo containers move through ports around the world. Under the hood, we have three big roles. First, the mail user agent, or MUA. That's your Outlook, Thunderbird, or Apple Mail, even webmail in the browser. That's the interface layer. Then we have the mail transfer agent. Software like Postfix, Exim, or Microsoft Exchange. The MTA is the postal service of the email world. It deals with routing, queuing, and retrying. Finally, we have the mail delivery agent, the MDA, which is part that actually drops the message into the right mailbox on the disk or in a database. None of this works without DNS. DNS is the galactic address book of the internet. When the MTA needs to deliver a message to the user at example.com, it goes to DNS and asks, hey, which mail server is responsible for example.com? DNS answers via the MX records, and off the message goes. Think of it like the Star Wars Holonet. Email is the message, MTAs are the relay buoys, and DNS is the nav computer that tells you which hyperspace lane to take so you don't jump into a star. At the base, we have DNS on port 53, quietly doing name resolution for everything. When your mail server wants to deliver to another domain, it performs a DNS query lookup to the MX record for that domain. That record says send mail to this domain, mail.evil.corp. Without DNS, email basically goes blind. A typical flow looks like this. First, the user's MUA submits the email to an outgoing server using SMTP. That server is running an MTA. Again, something like Postfix or Exchange. The MTA then goes to the DNS MX lookup for the recipient's domain. Once it knows where to go, the sending MTA opens an SMTP connection, usually to port 25 on the receiving MTA, and transfers the message. The receiving side passes the message to an MDA, which stores it in a mailbox. That might be an mbox file, a mail diar, or a database backend store. Finally, when the recipient checks their mail, their MUA connects using POP3 or IMAP to read the message. So we separate three concerns. Submission is client to server. That's you handing the message to your provider. Relay and transfer is server to server. Different MTAs talk to each other across the internet. And retrieval is server backend to client. POP3 or IMAP bringing the content to the user. If you want, you can think of it like a sci-fi logistics chain. One system handles how do I drop the parcel into the network? Another handles how do I move it between planets? And a different one handles how does the person on the destination station actually pick it up from the locker? POP3. It's on port 110. It's the post office protocol, version 3. The mental model of this is very literal. You go to the post office. empty your mailbox, and walk away with everything. A POP3 client connects to the server, authenticates, download messages, and by default, in the classic model, it removes them from the server once they've been collected. It's simple, low overhead, and works well when you've got one device and a small mailbox. But as soon as you live in the modern world with a phone, a laptop, and maybe a tablet, POP3 starts to feel like trying to share a single physical notebook among three people. To fix the obvious security problem of credentials and content in clear text, we wrap POP3 in encryption. That gives us POP3 over TLS SSL on port 995, often called POP3S, or Secure POP3. The behavior is the same. It still downloads mail, usually to a single device. But now, the TCP session is encrypted end-to-end, protecting the username, password, and message contents from anyone sniffing around the network. But where does POP3 still make sense? Mostly in small, simple setups, embedded systems, old appliances, or environments where users genuinely only have one mail device and don't care about server-side folders or synchronization. Think of POP3 as the old school download your episode and delete them from the server workflow versus streaming everything on demand. It still works. It's just not how most of us live anymore. IMAP. This is on port 143. It's the Internet Message Access Protocol. Instead of treating the server like a temporary staging area, IMAP treats the server as the source of truth. Messages live on the server, clients just synchronize views, folders, flags, read and unread state, even partial message bodies. That's why you can read an email on your phone, archive it, and then see it archived on your laptop a few seconds later. The semantics are inherently multi-device. As with POP3, we then layer encryption on top of it. That's IMAPS on port 993. It's IMAP over TLS or SSL. The protocol is the same, but the entire connection is encrypted in transit, which protects both credentials and message content from passive eavesdropping or casual packet captures on the same network. Modern clients will strongly prefer IMAPs by default, and many providers will refuse plain IMAP entirely. From a best practice standpoint, the rule of thumb is use IMAPs 993 unless you have a very good reason not to, such as tunneling everything through a VPN where you control both ends. IMAP plus TLS is basically the Netflix model of email. Everything lives in the cloud. All of your devices stay in sync, and the wire is encrypted. POP3 is more like downloading an AVI file off a sketchy site in the early 2000s, then trying to keep track of which hard drive you left it on. Okay, SMTP on ports 25 is the original simple mail transfer protocol rule. It's how MTAs talk to each other across the internet. When one mail server needs to hand off a message to another domain, it opens a TCP connection on port 25 and speaks SMTP. That's the interdomain mail highway. Because of its age and ubiquity, port 25 is also heavily abused by spammers. So many ISPs now block or heavily filter direct outbound port 25 from end user networks. For clients submitting mail, we generally don't want them using port 25 directly. Instead, we use dedicated submission ports. Historically, port 465 became associated with SMTPS. SMTP wrapped in implicit TLS, where encryption is negotiated right at the connection start. Many modern providers, however, standardize on port 587 as the official submission port, using STARTTLS to upgrade the connection to TLS. In practice, port 465 and 587 are both used for secure submission from MUAs to their provider's MTA. while 25 remains server-to-server lane only. From a security configuration perspective, though, there are a few ground rules. First, always require authentication on your submission, port 465 and 587. No auth, no relay. Second, always encrypt those submission sessions with TLS, whether implicit on 465 via STARTTLS on 587, so credentials and message contents aren't exposed to the wire. Third, lock down your port 25 as much as you can, or as much as your use case allows. Restrict who can relay through it, and consider network level controls to reduce abuse. If we go full sci-fi on this, port 25 is the public hyperspace lane between planets. You don't control who flies through it, while 465 and 587 are the private docking bays, where only ships with proper credentials and clearance codes are allowed to actually dock.